pass by value. We talked about this in Unit 5, Section 2, and then mentioned it again in Section 4. And this is a rule Java follows when it's using parameters. When you call a method or a constructor that has parameters, you're providing information in the form of values. Java is careful with what it does with these. It is very specific. It makes copies of the values you provide to fill in its parameter variables to try and protect the original information. So I have some samples here to try and make this process a little more clear. So there's the temp methods class, and it has some methods in it. This is one such method, public void modify int. So it is a public method, it does not return anything, and its goal is to modify an integer. Really basic stuff, you don't need a method for this, but it helps prove a point. It has a parameter, int I. Now what we do here is we increment I plus equals 1, and then we print it out. So it's pretty straightforward. If I is 5, it's going to print 6. If I is 15, it's going to print 16. The thing that I would question, though, is if we give a parameter here and we increment it, does that change the original value? And pass by value says it shouldn't. So here I make a new temp methods, I make a variable called number, set it equal to 5, and I call this method with the parameter as number. So I'm giving it the variable, but what is it doing with it? Pass by value says we make a copy of the value. A primitive type is just the number, so it's just the integer. So we'll just make a copy of the number 5 and work with it. Which means after we run this, it'll print out its answer. It should print out 6 because we gave it the number 5. When we come back and print out number shouldn't have changed. And we can see that happen here, 6 then 5. So these primitive types are protected. Immutable types are also protected in a very unintuitive way, because when we start thinking about it, it seems like they wouldn't be safe. But here's what happens. When we pass an object in as a parameter, and it copies its value, what is stored in an object is a reference, a location to where that object is stored in memory. So it copies the value of the address, or it copies the address. So theoretically, you have access to the original object. You have an alias, right? A new way to refer to the same exact object. That means changes made could affect that original object. When an object is immutable, though, like a string object is immutable, it can't be changed. It could be completely replaced somewhere else, a new memory location, but the original would just sit there at its address with no changes. So we actually realized that when we do something like modify string, an immutable object, it has the same result, the same idea as a primitive type, even though it's an object. When we give it a mutable object, though, like a person is a mutable object, we get that really weird behavior. Changes to the object affect the original before it became a parameter, before it copied that address, because it can change what is living at that address. It can change that original person. So I provide a little bit of an example here. So we make this again, we make a string called hello world. We call modify string, and we print out the original string to see what happened. We can see down here, it did not add the exclamation point like the method did after the fact. So up here, we can see clearly it made a copy of the string that it edited and didn't affect the original address. On the other hand, though, person1 equals new person, Mr. G25. Modify person should give that person the name new name, erase their old name and replace it, and then print their name. So as we'd expect, it's going to print at first new name, but then when we leave the method and we come back and we print person1.getName, outside of this method, the name is still new name. We changed the original object because a person is mutable. We copied its address, and whenever we do something to that address, we change the original object, the original person. And so that change affects all the way out here, even once the method is over. This is a super important concept, and that's why I keep talking about it, right? Third time in the 6 or 7 sections we've covered that this keeps coming up because it is so important. In summary, pass by value means a method cannot modify parameters that are based on primitive values or immutable objects, but can modify parameters that are based on mutable objects. So it can't edit int double boolean or string, but it can edit person as an example. So now let's talk about what's going on with private data.